Picking up where we left off, we just discussed how when I looked at this equation, it was not set equal to 0, so that's the first thing that we had to do. Remember, we want to move everything over to the side where the x squared term will remain positive, so I subtracted 8x from each side and added 1 to each side, thus canceling these out, leaving us with 0, and on the left-hand side, we have 16x squared minus 8x plus 1. Now, when I look at this, I immediately see perfect squares. I see 4x being squared to get 16x squared, and I see 1 being squared to get 1. So when I see example 6, I want to try and see if I can use a perfect square trinomial. So if I have a squared minus 2ab plus b squared, I would be able to write it as a minus b being squared. Well, a would be 4x, b would be 1, 2 times 4x times 1 would be 8x. So I do have a perfect square trinomial. I can go ahead and write it as 4x minus 1 squared equals 0. And then I'm already done factoring and I can solve. If you saw this initially and checked for a GCF, you didn't notice it was a perfect square, and you wanted to solve it as a not being equal to 1, so box method, that is an option as well. I wanted to show you that if we were to do that, if we were to set up a box, first term in first box, last term in last box, multiply, write out the factors, you could factor it and notice we get 4x minus 1, 4x minus 1. Something times itself can be written as something squared. So really you have two options here. It's up to you which one you want to use. I personally think this one's faster, so that's the one I use. Alright, I'm not done yet. Because it's set equal to 0, I need to solve. To undo the square, I need to take the square root of each side. This will cancel each other out, leaving me with the 4x minus 1. Now technically, when I take the square root, I need to put a plus or minus out front, but because this is square root of 0, that doesn't matter. It will become important later on, that's why I'm mentioning it, so I'm just going to put equals to 0 right now. And to solve for x, I add 1 to each side, leaving me with 4x equals 1. Divide by 4, I get 1/4. So I have one solution of 1/4. Example 7. Once again, it is not set equal to 0, so that's the very first thing I'm going to want to do. Just getting situated here. Remember, we would like to move it to the side that would keep the y squared positive. So I have two y squares in this problem, a positive 2y here and a negative 2y here. If I were to subtract the 2y over to the other side, I would end up getting a negative 3y, and that's not what I want, that's negative. But if I move the negative y squared over to the other side by adding y squared, I would get a positive 3y, and that is what I want to do. So I have 3y squared. That cancels out. I also need to move the y over. So negative 4y minus y is negative 5y. And then minus 8, because I can't forget about that number there, equals 0, because I removed everything from this side. Check and make sure that there's no GCF, and there is not. So what I need to do now is go ahead and factor. A is not equal to 1, so we'd have to use the box method. Let's do a little refresher there. Make my box. First term in the first box, last term in the last box. Multiply these two things together. I get negative 24y squared. This negative tells me I need to use different signs. I can list out all of the factors of 24. That's 1y, 24y, 2y, 12y, 3y, 8y, 4y, 6y. Using different signs, I need to get the middle term of negative 5y. Let's go show up a little bit more. Negative 5y, that would be the 3 and the 8, where the 8 must be negative and the 3 must be positive, because again, I want a negative 5y. All right, plug those in. I'll put my 3y here, negative 8y here. Doesn't matter if you have those switched or not. And then we need to pull out the GCF. So the GCF between these is a positive 1. It's positive because the outermost box is positive, and there's nothing that they're both divisible by other than 1. Here, they both contain a y, so I can pull that out. And the numbers, the GCF is just 1. So you can put a 1y if you want, or just leave it as y. Here, they're both divisible by 3, so a 3, and they both have a y, 3y. And then lastly, they both are divisible by 8, and I would want to put negative because the outermost box is negative. So now I know I have y plus 1 times 3y minus 8, set equal to 0. Set both parentheses equal to 0, so y plus 1 equals 0, 3y minus 8 equals 0. Solve, I subtract 1, I get negative 1 as a solution. I'd add 8 and then divide by 3, I have y equals positive 8/3. All right. For examples 8 through 11, we are now rewriting from standard form, ax squared plus bx plus c, to intercept form, which is a times x minus p times x minus q. Starting with number 8, all I have to do to get it from standard form to intercept form is factor it. I see that this is a equals 1. There's no GCF, so I can use the guess and check. Y equals, if I think about the factors of 12, that's 1 and 12, 2 and 6, 3 and 4. Using same signs, what could give me positive 7? Well, that's a positive 3 and positive 4. So y equals x plus 3 times x plus 4. Now, it's not set equal to 0, so I'm not solving for anything. The directions just asked to rewrite it into intercept form, and I have. Side note, if this is intercept form, A is 1, P is negative 3, because the form is x minus P, and Q is negative 4, x minus Q. Remember, P and Q are x-intercepts. If I were to solve set equal to 0, x plus 3 equal to 0, I'd get negative 3. X plus 4 equal to 0, I'd get negative 4. Remember, when we're solving, we are finding the x-intercepts. So I just wanted to show you that correlation real quick. Example 9, I have a binomial, so 2 terms. When I look at this, I see that they are perfect squares of x and 2. So I can use the difference of 2 squares rule, which is x plus 2, x minus 2. If you didn't have that rule memorized, you could also rewrite it as y equals x squared plus 0x minus 4. List out the factors of 4 and treat it like a guess and check. So using different signs, what could become 0? Well, minus and plus, you'd have x minus 2, x plus 2. All right, example 10. Here, I do have a GCF of x. So if I pull out an x, I divide each term by the GCF to get what remains in the parentheses. So that'd be x minus 3. And I cannot factor that any further. The x-intercepts here, by the way, would be 0 and 3. If I were solving this, I would set both equal to 0. X equals 0 gives me one solution. x minus 3 equal to 0 would give me a solution of positive 3. And example 11. I put another one of these in here because, again, this is something that people struggled with, so I'm going to star it. We would like to have the first term be positive. In this case, it is not. So I need to pull out a negative GCF. And all of these terms, the numbers don't have a GCF greater than 1. So I'm just going to pull out a negative 1. By doing that, I now can change all the signs. I have x squared minus 16x plus 64. And remember, we're rewriting it, so I need to put that y equals still. But I'm not done yet. This still doesn't look like intercept form, which is parentheses next to one another. So I need to factor this. Lucky for us, it's the easy one because a is equal to 1. So I can just list out all of the factors of 64. And using same signs, I want to get a negative 16x. So 1 and 64, 2 and 32, 4 and 16, 8 and 8. That would have to be negative 8 and negative 8. If you wanted to, you could also write it as y equals negative x minus 8 squared, because technically anything times itself is something squared. And in this case, if I were to set it equal to 0, negative 1 would not give me a solution, so the GCF does not give me a solution like example 10 did, but I would get one solution of positive 8 here by taking the square root and then adding the 8.